More hardware issues in Linux. In this video, we'll talk more about hardware for your Linux system. First, we'll cover some terminology, and then we'll explain troubleshooting specific hardware problems. Another topic we'll cover is running Linux on your laptop computer, and some of the special considerations involved with laptops and Linux. So let's get started. Let's start with a discussion of IDE devices. IDE stands for Integrated Device Electronics, and then there's EIDE, which is Enhanced Integrated Device Electronics. These devices are also known as ATA devices, which stands for Advanced Technology Attachment. So when I'm talking about IDE devices, I'm talking about anything with one of these three names. So Linux supports 2 IDE controllers, and each controller itself can support 2 IDE devices, so that gives you a maximum of 4 IDE devices on your Linux system. Now, a typical IDE device would be like a CD-ROM or a hard drive or something like that. Now, if you have an IDE hard drive and you think it's not performing up to par, then what you can do is you can do a test on it. You can say HD Parm with the lowercase t option and then specify the disk that you want to test, like like /dev/HDA or something like that. So you'd specify this, and then it would test the disk transfer rate of that particular disk you specified. It would do a bunch of transfers and then give you some sort of summary information like the disk transferred 15 megabytes per second. Okay, and then what you do with this number is you either compare it to a previous run of HD Parm, and if it used to run at 15 megabytes per second and it still runs, then you know it's okay. If it used to run at like 25 megabytes per second and now it's 15, you can suspect that something's wrong, and we'll talk about what you can do there. Now, another thing you could do with this 15 megabytes per second is just compare it to the manufacturer's specifications. So if you've never run HD Parm before on this disk, this is the only number you have, like the only experimental thing that you've ever done on your disk, then you'll have to compare it to the manufacturer's specifications. So the manufacturer's specifications can be a little misleading sometimes, and you have to be really careful when you read them. Some manufacturers will advertise their disk transfer rate in megabytes per second, and they represent that with a capital B. Other manufacturers will represent disk transfer rates as megabits per second with the lowercase b. All right, so you have to be careful when doing this. I mean, it's an uppercase b, lowercase b. You could easily overlook that, but this is a factor of 8 different in the numbers. So something that was advertised as 10 megabytes per second, this thing would have to be advertised as 80 megabits per second to be equal with that. All right, so that's quite a difference, and you have to keep your eye out for that. Another thing you have to worry about with manufacturer specifications is whether they're advertising internal or external transfer rates. Now, internal transfer rates are what the drive can transfer, and external transfer rates are what the bus can transfer. So here's your hard disk, okay? And it's hooked up by this bus to your motherboard, and it's plugged into your motherboard, and it's transferring data across the bus. Well, typically the bus has much greater bandwidth, can transfer data much more quickly than the disk can. So usually the disk is the bottleneck in this equation. So it's like a highway, right? Like the bus is like a 6-lane highway, and then the disk is like a 3-lane section of that highway. So it doesn't matter that the 6 lanes, can pump all these cars through. They're all going to have to go through that 3-lane section, and that's going to slow things down. All right. So a lot of times you'll see manufacturers advertise external transfer rates even though they're larger than the internal transfer rates, and you'll never actually realize this in practice. All right. Other people will advertise internal transfer rates. Most drives will advertise this, but it'll be buried down on the spec sheet a little bit. This will be up at the top, prominently displayed, because it's a bigger number, and it makes them sell more disks. Okay, so you just have to be a little bit careful here. And even the internal transfer rate, I mean, you're not going to get 100% of that for every data transfer. You're typically going to get like 80 to 90% of the manufacturer's advertised internal transfer rate. That's what you'll realize in practice, just because when they do the test and they say what the maximum internal transfer rate is, they've got some file contiguously laid out on the disk, so the transfer is going to be done perfectly. In practice, the files get scattered around on the disk, and there's more spinning that the disk has to do to get all that stuff. It's what we call seek time. The files have to be found and then transferred, and they're not laid out perfectly all the time in practice. So that's why you'll only see like 80 to 90% of the internal transfer rate. Let's talk about what you can do if you run into problems with your IDE hard disk. The first thing that you should try and do if you're having problems with the disk, like the disk isn't booting or the transfer rates are really bad, check for loose cables or faulty cables. If you have a spare cable that you can plug in and try in place of the cable that you have now, that would be great. That's a good first test, because a loose cable or a faulty cable could cause all kinds of problems, everything from the disk not booting to transfer rates being low, that kind of stuff. Another thing that you can try is to get diagnostic tools from the manufacturer of the hard disk. So go to the manufacturer's website and download some stuff, and that stuff will be the diagnostic tools, and it should typically all fit on a floppy, and they'll also make it so the floppy's bootable. So you can stick the floppy into your computer and boot up your system, and then it'll boot you into the diagnostic tools for that particular disk. And when you download that information onto the floppy, also download some stuff like a manual or some sort of help sheet that will guide you through the process to diagnose the problems on your disk. So this is a good tool, and this is going to be very manufacturer dependent. That's why I said get that help sheet or get that manual, because that's going to help guide you through the process to determine what's wrong with your disk. Another thing you have to check are master-slave settings on IDE hard disks. So before we saw a picture of a motherboard, and on the motherboard there was this port, this slot for IDE devices. And I told you earlier that those IDE controllers themselves can control 2 IDE devices. So typically, you know, the picture that we saw before of an IDE hard disk hooked up to our motherboard, it was just one hard disk and the cable was like this plugged into the motherboard. Well, you can also get a cable that will extend like this to another hard disk, all right? And then you can have 2 hard disks on this one port. So that's nice, because if you need lots of disks, you can plug 2 into this one port. You have to be a little bit careful, because the performance isn't going to be as good as two separate disks. So if you have 2 IDE ports on your motherboard, which most motherboards do, and you only have 2 IDE disks, you should probably just plug 1 into each port. You're going to get better performance. But if you need it, if you have like 3 or 4 IDE hard disks on your system, then you're going to have to do this chaining, we call it. And this chaining, basically what this amounts to is that the one that's first in line to the actual port is called the master, and then the one that's second in line over here is called the slave. Okay? And you need to make sure that these are configured correctly, and the way that you configure these as master and slave typically is with jumpers. So on the back of the disk drive, in between the connector for the power and the connector for the ribbon cable, is this area for the jumpers. And there's these pins sticking out like this, and you've got your jumper, and it's going to slide over some pair of these pins in this vertical direction. All right, and typically they've got something like this: MA for master, SL for slave, that kind of stuff. So you would put the jumper over these 2 pins if this was the master disk, and you would put the jumper over the next 2 pins here if it was the slave disk. And you have to make sure that's configured correctly. The first one in line's got to be the master, the next one's got to be the slave. If they're both masters or both slaves, or vice versa, if this one's the master and this one's the slave, then things aren't going to work, things aren't going to boot up, and you just need to be careful that you've set this up correctly when you add it on these hard disks. And then another thing that you can do, I put at the end of the list because it can be a little bit dangerous, is use the HD Parm utility. There are some, besides just testing the performance of your disk, it can also fix some various issues or change some settings of your disk. It can change it from like DMA mode to PIO mode. Okay, DMA mode is direct memory access mode, and in that mode the CPU is really not doing as much stuff. It's downloading a lot of the work off to the controller itself to handle disk transfers. PIO mode, the CPU is dealing with all the data transfers. So PIO mode generally loads up the CPU more. DMA mode takes load off the CPU, and you can experiment back and forth with these, see which one's better. You can set the various levels of PIO mode. You can do all sorts of things with HD Parm. And like I said, these can cause problems, so I don't want to stress too much here that you should try this. You really have to know what you're doing to use HD Parm, and you really need like a manual for the disk and some sort of information about how HD Parm will affect the performance of this disk. And certainly anytime you're going to use HD Parm in this mode, you should have a complete backup of your disk, a recent backup, because like I said, it could just completely damage your disk. Now let's talk about Scuzzy, which stands for Small Computer Systems Interface. Compared to IDE, Scuzzy devices are typically more expensive, and they're also higher performance than their IDE counterparts. So you just need to decide, is the extra money worth the higher performance for your particular situation? All the stuff that we were talking about in relation to IDE disks, like how manufacturers advertise the transfer rates and things like that, all that stuff applies to Scuzzy disks as well. So you need to look for that internal transfer rate and make sure you understand whether it's megabytes or megabits per second, just like you did with IDE disks. The thing that differentiates Scuzzy disks from IDE disks mostly is that the Scuzzy bus is very different. The Scuzzy controllers allow more devices per controller than the IDE controllers did. We saw the IDE controllers only allowed 2 IDE devices per controller, and for Scuzzy that number is